We're back with part 3 of our Fun with Statistics. The fun never stops, and now we get to talk about noisy numbers. What do I mean by noisy? Just that every time you ever hear a statistic, there's often a lot of noise behind that number. We make it seem like the number is real. Whenever you hear 76.3% of people are vaccinated in the state of Vermont, you think, wow, that's amazing that scientists know this exact number. Well, they're giving you an estimate, right? They're giving you the best that they know, but there is still a lot of noise involved. So here's a couple examples of how, when you ever hear numbers, you want to be thinking, what does it really mean? I'm going to start in the professional basketball arena with free throw shooting. So here are the 3 best professional free throw shooters. Number 1 is Elena Deladun. She shoots almost 94% in her career from the free throw line. That is just amazing, especially for a taller woman. She's 6'5". Usually the taller people aren't quite as good. Steph Curry, almost 91%. But you get the idea. These people are hitting 9 out of 10, maybe 19 out of 20 often free throw shooting. That's just amazing. But if any one of these people were to come to you and say, I just shot 98 out of 100 in a row, I bet you I can get 99 or 100 on the next group of 100. I would take that bet. And it's not because any of these 3 are not just amazing, and they're certainly capable. I bet in practice, maybe even they've had a streak of 100 in a row. Wouldn't doubt that that's possible, but statistically speaking, they're unlikely to beat 98, especially if they just did it, right? Because 98 is a little bit outside of the norm, a little bit away from their mean, and it is likely the next time they will regress back to the mean. So one of the reasons numbers are noisy is there is this phenomenon called the regression to the mean. It is really hard to have like an abnormal year and then not have the next year be abnormal again, or even better. So here's an example. Here's Elena Deladun's free throw percentages over the years. You notice she does seem to hover pretty around 93, 94%. A couple years ago, had for her one of the worst years. 89% is still just amazing. That'd be one of the best ever. Then the very next year, she hit just 117 out of 120 free throws. Just amazing. 97%. By the way, the next year she only had 12 free throw shots before getting injured. She hit all 12 of them. But you see here, she's got 97%. I think statistically speaking, it is extremely unlikely that she would hit 97, 98, or 99 the next year. I'd love to be proven wrong, by the way. That'd be great to see. But you see, after hitting 88, she jumped back up. It is likely that she has some mean here. And anytime she goes too far from that mean, the next year is much more likely to be closer to that mean. This is just called regression of the mean. It's a statistical phenomenon. Again, I don't mean to make anybody into betters, but you get the idea that when somebody does something amazing, I wouldn't think that this is a progress up to 99 the next year. It's very likely for her to come back down. So we'll watch her career and Steph Curry's career and see if that's true. More commonly, though, when we look at fuzzy numbers, it's usually because of averages, right? Here's a group of people, and this is a scale of pain. I'm just making up the data, right? But if you say 10 is the most excruciating pain you've ever been in, you get a bunch of participants who are in a lot of pain, and you give them a pretest, and you say, how much pain are you in? And let's say that they all score above a 7, but the average is 8. And you even might say, in a pretest, we have 40 people with 8.1 pain level, right? And that 8.1 sounds so real and so accurate. But remember, there's some noise involved. We have people in much more pain than somebody else, right? The difference between a 9.3 and a 7.1 might be pretty big if you think about it. But for the purposes of this, let's assume that we come up with some awesome painkiller, right? We came up with a brand new medication, and we do a post-test, and oh, the data is just so good, right? It's not perfect. Nobody goes to 0, but we've got people almost, in fact, every single participant here now is below a 7. A couple people didn't feel that much better, but everybody felt somewhat better. The average might be closer to 4 here. And this is kind of a slam dunk study. If this medication was not addictive and there were little to no side effects, this would be an amazing medication, and I would be so happy. But what tends to happen, and again, even this is somewhat fuzzy, right? There's some spread here. Somebody went down to almost no pain at all. Another person barely moved down, but still, we'd be like, this is a great drug. However, this is more likely, right? We get a bunch of people who didn't even get better. Some people did get better. On average, they absolutely went from, say, 8.2 down to a 6.5. I would still say, yeah, this drug is worth trying, right? You might be one of these people who it doesn't help. By the way, a couple of these people here might have gotten worse, right? So we don't even think that it helped everybody. But this is more common, right? That there's tremendous spread, and it includes a subgroup of people that might not have gotten better, maybe even a couple of people that got worse. You might start thinking, though, that what if it's not just the medication? What if just this is a 2-week delay between pre-test and post-test? What if people just feel better? What if the pain just goes away for some of these people? So you'd also want to have a control condition and then a placebo condition, right? Maybe that's because we give some people the pill, and the idea of getting a pill makes them feel better. So what if the data looked like this? Again, I hope people see what I'm trying to get at. Is there's some noise involved, right? The control condition, good group of people felt a little bit better. That just happens over time, right? Pain tends to go away, tends to go up and down, and so this might have been when they were feeling better. A little bit, by the way, not by a lot. The placebo group here, again, this is made up data, but let's assume that there is some placebo effect that kind of lowers it for most people. They're taking a pill, so they think maybe they've got a mindset of recovery. Maybe that distracts them from their pain. Maybe they actually have biochemical reactions to that belief, right? But it helps a little bit more, but it's not as helpful as the treatment condition. And again, if this were the results, I would be pretty excited, right? To go from an average around 8, control condition is closer to 7, placebo group maybe 6.5. But our treatment group is definitely better. They're not all better than control and placebo, but yeah, it's pretty clear that it's down here. Again, with no or little side effects and with no addiction, I would say this is a great drug. But what if the data is a little more noisy than that, right? What if there's not as tremendous? What if there's more overlap like this? Then you start feeling a little less excited. Even here, though, I would probably still be like, yeah, that's statistically lower amounts of pain than either control or placebo. Okay, here's another example. Oh, the spread. Look at this. Not everybody feels better. Again, some people, even in the treatment condition, aren't getting that much better. And finally, what about this condition? And I would say this is pretty realistic, to be honest, that the noise is tremendous. That first of all, our pretest, it's hard to get a group of people that are all just 7 to 9, like in the first example. I put in more dots here. I think this is more realistic. You got kind of some diversity to begin with. And then our control group, right? A lot of them don't feel better. Some do. Placebo's it's better, but there's just so much spread here. And then our treatment condition might be a little bit lower, but this is a tough one. When you look at the graph like this, you're a little less excited about this particular pill in this case, or whatever the treatment might be. Let's run the numbers, and you might actually end up with a statistic that says from this data set that the treatment condition is 100% more effective than no treatment, and the control 50% more effective than the placebo. Wow. Again, these numbers just sound so persuasive and sound like if you didn't look at this graph and all you saw was this statistic, you'd be like, that's amazing. This drug is a slam dunk. But this graph does end up concluding 100% more effective than no treatment. What? Well, remember, we're comparing our pretest to our control group. The average went down from a 7.8 to a 6.8. And then the treatment group the average was 5.8. And again, I'm making this up. I don't know if that represents these numbers very well, but let's say this is true. Pain reduction of 1 for the control, the pain reduction of 2 for the treatment means that the treatment group is 100% better than the control relative to our pretest. This went down by 1, and the treatment group went down by 100% more than that. And again, the 50% comes because the placebo is in between. So 50% more effective than the placebo relative to the control. You get the idea that that's how they can come up with statistics. So all this to say, I just strongly encourage everybody, whenever they see graphs that they don't understand, and then this is how it gets summarized, a lot of people just kind of roll their eyes and think that's not all that important. But to me, it's extremely important, because decisions about medications, how effective they are. Again, if I were to give this drug to somebody, I would be very careful not to use this language myself. And I would also point out, right, there's a lot of people who may not get better or noticeably better. I still would probably recommend the medication, again, particularly if it has low side effects and is not addictive. So what's my takeaway from this video? Number one is just that research is complex. I'm sorry to just kind of throw numbers at you, but you get the idea that it's not as simple as just a headline that makes it sound like sometimes that's all you will hear is that some drug is 100% better than a control group or 50% better than a placebo. So beware of those headlines. And finally, I will say, scientific method is flawed. I still think it's the best thing out there. I don't want to be too skeptical, too anti-science. It's not my goal. In fact, I'm very pro-science, but just the way it gets communicated as a headline sometimes, I hope people are willing to do the digging and find out more. All right, thanks for coming with this journey with me. I hope you had some fun.